In this tutorial we will discuss process involved in fluorescence. In this process, the initial absorption takes the molecule to an excited electronic state. The excited molecule undergoes collision with the surrounding molecule, and as it gives up energy non-radiatively to the surrounding molecules, it steps down the ladder of vibrational levels to the lowest vibrational level of the electronically excited molecular state. The surrounding molecules might not be able to accept the larger energy difference needed to lower the molecule to the ground electronic state, so it emits the excess of energy as radiation. The downward electronic transition is vertical in accord with Franck-Condon principle, and we all knows that electronic transition takes place in accordance with Franck-Condon principle, and the fluorescence spectrum have a vibrational structure characteristics of the lower electronic state. Thus, in fluorescence, the excited molecule first undergo non-radiative decay and loses its energy to the surrounding molecules, and at last a radiative decay in which it discards its energy as photon. The 0-to-0 absorption and fluorescence transition can be expected to be coincident. The absorption spectrum arises from 1-to-0 transitions, 2-to-0 transitions and so on transitions, and occur at progressively higher wave number and width intensity given by Franck-Condon principle. The fluorescence spectrum arises 0-to-0 transitions, 0-to-1 transition and so on downward transitions, and hence occurs with decreasing wave numbers. The 0-to-0 absorption and fluorescence peaks are not exactly coincident because the solvent may interact differently with the solute in the ground and excited state. For instance, H-bonding may differ, because the solvent molecule does not have time to rearrange during the transition. The 0-to-0 absorption occurs in an environment characteristics of the solvated excited state. The fluorescence occurs at a lower frequency than the incident radiation because the emissive transition occurs after some vibrational energy has been discarded into surroundings. For example, most dyes absorb in the ultraviolet and blue, but fluorescence invisible. The intensity of fluorescence also depends on the ability of solvent molecule to accept electronic and vibrational quanta. It is found that a solvent composed of molecules with widely spaced vibrational levels like water can in some cases, accept the large quantum of electronic energy and so extinguish or quench the fluorescence known as fluorescence quenching. This much for today, thanks for watching, bye bye, see you.